what are the roots, relations on roots, and then finding equation if roots are given. We discussed everything. And now if you look at this, if you have an equation like this, it may be your 15th point, I think so. If you have an equation like this, ax square plus bx plus c is equals to 0, as per our discussion, the roots of this equation are given as minus b plus or minus square root of b square minus 4ac by 2a. Is it clear? Minus b plus or minus square root of b square minus 4ac by 2a are the roots for the given equation, which is ax square plus bx plus c is equals to 0. Now, see, in finding the roots or using this formula, the nature of the roots we are going to decide, right? What we are going to decide? We are going to discuss about the nature of roots. Nature of roots means how the roots are there. See, in which country, in which number system the roots are located. That's what we are going to find. See, in which number system the roots are located. That's what we need to find, and we have different types of number systems, right? That means different types of countries like natural numbers, like that integers, rational numbers, irrationals, reals, and we introduced complex also. We have to decide that where the roots are located, in which number system they are located. That's as nature of roots we discuss here. See, the total theory depends upon the value of this b square minus 4ac, because it is under the square root, right? Under the square root we have b square minus 4ac, and that b square minus 4ac value discriminates the nature of the roots. So what I am going to tell you is this b square minus 4ac will discriminate the nature of the roots. Depend upon the value of this b square minus 4ac, the nature of roots will depend. So this b square minus 4ac is usually denoted by the letter delta, or in some ways it is denoted by d also, and this is known as discriminant of the equation. What we call it as discriminant. Keep in mind that this b square minus 4ac is the discriminant of the equation. It discriminates the nature of the roots. Depending upon that value of b square minus 4ac, we will decide the nature of the roots. So for example, initially if you have an equation ax square plus bx plus c is equals to 0, and for that equation ax square plus bx plus c is equals to 0, clearly the values a, b, c are the real numbers. See, in the previous classes we found certain equations where the coefficients are imaginary also, right? But at present our discussion, our task deals with the quadratic equations of this format whose coefficients a, b, c are real numbers only, right? First of all, assume that a, b, c are real numbers, right? See, if we have an equation, observe that whether a, b, c are real or not. Usually you will get the real coefficients equations only. And after identifying that a, b, c as real numbers, you just find the delta value. Delta value means discriminant value. Why we are finding the delta? Because we are going to decide the nature of the roots, right? So find the delta value b square minus 4ac. And if you find the delta value b square minus 4ac, there you may face different situations that delta value, this is a real number, right? A, b, c are real, and b square minus 4ac is also a number, and if you find the value delta may be less than 0, the value delta may be is equals to 0, the value delta may be greater than 0. If you find the b square minus 4ac value, then that b square minus 4ac delta value is either positive or negative or maybe equals to 0. Now, depending upon the delta, you need to decide what is the nature of the roots. Think a while. I will check one by one. Is it right? First of all, if you check for delta is equals to 0. Look here, the delta is 0. Delta 0 means what? See, this is minus b plus or minus, I may rewrite it like this, minus b plus or minus the square root of delta divided by 2a. Is it right? And now the delta is 0. Since delta is 0, this root delta won't be there. See, that is 0 actually. Delta 0 means root delta 0. Since root delta 0, what we have here? Minus b plus or minus 0 by 2a. Minus b plus or minus 0 by 2a means there is no meaning for plus and minus because it is plus or minus 0. Then in that case, we won't have two roots. We have only one root, and that is minus b by 2a. Okay, what I am going to conclude you is, if delta is equals to 0, we have only one root, or you may say it as equal roots. Okay, one real root, or you may say equal roots. Equal roots means the two roots are equal, and that equal root is again what it is, minus b by 2a. There is only one root. Okay, and if you say them as two roots, they are equal. Okay, in any way you can think it, and that root value is just minus b by 2a if delta is equals to 0. Once again I am repeating you, if delta is equals to 0, then we have only one root, and that root is minus b by 2a. Whereas coming to the last case where delta is less than 0, think about it. Delta is a negative number. Under the square root we have a negative number. As we discussed in the previous class, under the square root, if you have a negative number, then the square root value will come under the imaginary quantity. As we discussed that root of minus 4 is 2i, root of minus 9 is 3i, like that. Since delta less than 0, then root delta is what? Root delta is an imaginary quantity. That in the sense, if delta less than 0, then this given equation ax square plus bx plus c is equals to 0 has no real roots. So at this case we will confirm that the given equation has no real roots. No real roots in the sense, it means it has imaginary roots, or you may say complex roots also. What you are going to say? We are going to conclude that if delta less than 0, then the equation has no real roots, or in other words, we will confirm that the equation has imaginary roots. And in particular, A, B, C are real. Look once again, we did few problems at the end of the last session that if the equation has two roots, see the equation has two roots with the real coefficients. Think about it, the equation is with real coefficients, then what you say about the complex roots of the given equation? See, the complex roots of the given equation must be of the format some p plus iq and p minus iq. Why? Because you need to go through the previous session problems. Okay, yeah, see, with the previous knowledge that we have a chance to conclude that since the coefficients are real, identify it, the coefficients are real, that was important here. Since the coefficient a, b, c are real, then the roots, imaginary roots, may exist like this, p plus iq and p minus iq, and these two are usually called as conjugate pairs. What it is? Just it's a change of plus and minus sign, right? These are called as the conjugate pairs. Okay, so no need of the name, you just think about that. Since the coefficients are real and delta less than 0, the equation has no roots, no real roots. That means it has imaginary roots, and the imaginary roots must in the form of p plus iq and p minus iq. See, these type of pair of roots will exist only if the coefficients are real, or otherwise we won't get these type of roots, maybe in any other different way, right? So at the end, to decide the nature of the roots, to discriminate the nature of the roots, we need to think about what? Delta. The delta value b square minus 4ac is the discriminant, and that discriminant value may be is equals to 0, maybe less than 0, or maybe greater than 0. If it is equals to 0, we have only one real root. If it is less than 0, we have no real roots. And in the last case, if it is delta greater than 0, then we say that we have two real roots. What we say? We have two real roots. Or in other words, we say that distinct roots. Okay, see, if delta is equals to 0, we will announce in two ways. In the one case, we announce that the equation has one real root. In other words, we announce that the equation has equal roots. Whereas in the case of delta greater than 0, we have a chance to confirm that the equation has two real roots or the equation has distinct roots. That's it. Okay, and now look at this. See, delta greater than 0. See, a delta is a number under the square root. See, whether the square root value exists or not, that means what you say about the delta, whether the delta is a perfect square or not. Again, to decide the nature, we need to think about then what you say about the delta. Again, we have two chances here from. Delta is positive, but what we are going to say? Delta is a perfect square. Yeah, and delta is not a perfect square. Again we have two options here. See, in one option delta is a perfect square. I think you know about the perfect squares. See, what are the perfect square usually? 1, 4, 3 square 9, 4 square 16, 5 square 25, 6 square 10 square, 11 square. All these values are the perfect squares. See, if the delta is a perfect square, then if you have that perfect square under the square root, it is easy for us to find out the square root. If delta is not a perfect square, just like 11 or 12 or 13 like that, then root 11 we don't have a chance to simplify further. So you need to think that whether delta is a perfect square or not. If delta is a perfect square, see, there is no square root term, then for sure the roots are rational. If the delta is a perfect square, then the roots are rational. Okay, whereas the ABC also should be rational numbers. See, ABC are real numbers actually, and in real numbers also we have different groups, right? See, real numbers may consist of rational numbers union irrationals, right? And now see, if delta is a perfect square and ABC are rationals, then the roots are rationals. And now at the last case, if delta is not a perfect square, see, delta is not a perfect square, then in that case you need to think about again what? ABC. If ABC belongs to rational numbers, delta is not a perfect square and ABC belongs to rational numbers, then with this complete theory what we have is, if one root is p plus root q, then the other root is p minus root q. This is also as per the last class discussion. See, in the last class we found different equations with the rational coefficients where one root is of the format 2 plus root 3 like that. See, if one root is some 2 plus root 3, since the equation has rational coefficients, A, B, C belongs to rational numbers, means the equation has rational coefficients. So in that case, the other root must be p minus root q, or otherwise you can't get the sum of the roots and the product of the roots as a rational number. Okay, at the end of this total picture, what you need to memorize is, if delta greater than 0, the equation has two real roots or distinct roots. If delta is equals to 0, the equation has one real root, or you may say it has equal roots. If delta is less than 0, the equation has no real roots as well as it has imaginary roots. And further, if you think, if ABC belongs to R, then the imaginary roots are of this format. If one is p plus iq, other one is p minus iq. And if delta is not a perfect square and ABC belongs to rationals, then the irrational roots will exist again in conjugate pairs if one root is p plus root q and the other root is p minus root q. Have a look about the total picture, and this classification will decide the nature of the roots depending upon the discriminant value. And the discriminant value here it is b square minus 4ac. Right? Have a look at this. Go with the screenshot. See, these are few simple problems related to the nature of the roots. Okay? Think about the first question. The first question is what? 2x square plus 3x minus 4 is equals to 0. And we need to check the nature of roots for this equation. If you compare with our usual general form, ax square, bx and c, the value of a is 2, the value of b is 3, and the value of c is minus 4. Then from there you just find the value of delta. Delta is b square means 3 square minus 4 into a into minus 4. 4ac, no? Delta is b square minus 4ac. 3 square minus 4 into 2 into minus 4. And on simplification, exactly we don't need the value, just it is enough if it is positive or negative. Right? 9 plus it is 32 and that value is greater than 0. And it is very clear that since its discriminant is 0, what you say about the nature of the roots? See, you will say that the equation has real roots and the roots are distinct again. And once again, if you think, what is the value of delta? 32 plus 9 is 41, which is not a perfect square. Since it is not a perfect square, and if you look at the roots are rational clearly. 2, 3, minus 4 are the rational numbers, no? Then we will confirm that this particular equation has irrational roots, and for sure the roots are of the format p plus root q and p minus root q. Is it clear? Once again I am repeating you. See, if you have options, you need to choose the option related to this nature. See, we have different comments related on the nature of the roots for this equation. See, one thing is the roots are real, right? And the other thing is the roots are distinct. Okay? And the third thing is See, the roots are irrational in particular. And the fourth thing is the irrational roots are of the format p plus root q and p minus root q. All these are different comments related to the nature of the roots for this particular equation. You need to choose one option among the given four which suits the nature of the roots. Right? Once again I am repeating you. Look at this. To decide the nature of the roots, you need to compare with the usual expression, general form. From there a is 2, b is 3, c is minus 4. After having ABC, just try to find the delta. And based on this delta, I am going to conclude different observations on the roots for that particular equation. Since the delta is greater than 0, the equation has real roots. Since the delta is greater than 0, the roots are distinct. Since the delta value is not a perfect square, the roots are irrational. And since the coefficients are rational, then it is easy for us to decide that the roots are of the format p plus root q and p minus root q. All it happens just because of the complete analysis related to the nature of the roots. And that's the first question, right? Then think about the second question. Yeah, the second question is that, see, if one root of that x square plus 2x plus 5 is equals to 0 is p plus root q. Actually, it is the wrong thing. See, one root of that equation is not p plus root q, it is p plus iq. That's what I need to say. Yeah, now correct it and then try to solve it. If one root of x square plus 2x plus 5 is equals to 0 is p plus iq, then we need to find the value of p square minus q, whether it is possible or not. Okay, see, just it is a random question what I prepared from what I made, so maybe some corrections required here. So you need to correct it like p plus iq and correct it like p square plus q. First of all, since this is the equation, you need to think about the nature. Yeah, see, if you think about the nature, and for sure the delta value is b square minus 4ac. Here b is 2 square minus 4 into 1 into 5. A is 1, b is 2, c is 5. B square minus 4ac is equals to minus 16, which is less than 0. Since the delta is less than 0, what you say? The equation has what? Imaginary roots. And the imaginary roots are of the format p plus iq and p minus iq. Why? Because the coefficients are real numbers. See, as the given one root is p plus iq, and from our knowledge other root is p minus iq. And now I need to find the value of I did a mistake again. See, I need to find the value of p square plus q square. See, as per the question we need to generate, right? See, as per the theory we need to generate the question. So here for this particular question, if this p plus iq is the root for that, you need to find p square plus q square. That's my question actually. And now see, if one root is p plus iq, the other root is p minus iq. Since these two are the roots, if you multiply, it becomes the product of the roots. From here the product is what? 5. So product of the roots from the equation is 5, and from the observation of the roots, if one root is p plus iq and the other root is p minus iq, that is equals to 5. And now if you multiply these two, just it is nothing but p square plus q square. It is of the format x plus y into x minus y. X square is p square and iq square, I square is minus 1, right? So that's why, see, p square plus q square value is again 5. Just have a look at this. This is also one simple question related to the nature of the roots. First observation is that the equation has imaginary roots. Second observation is the coefficients are all real. No imaginary number involved in the coefficients. In such a case, if one root is p plus iq, the other root should be p minus iq. And since they ask us to find p square plus q square, just multiply these two, and the product of the roots is 5. From there, p square plus q square is equals to 5. There ends the second simple question related to the nature of the roots. And now you just have a look at the third question. Try to solve it. Yeah, I am erasing this. If you look at this, they ask us to find what? The equation has real roots, and we need to think about the values of t. See, you will get a range corresponding to t, a collection of values for t. Among the options, again you need to find out the suitable one. And now the equation is tx square minus 4x plus 3. If you compare with our usual general form, a is equals to t, b is equals to minus 4, and c is equals to 3. As they mentioned that the equation has real roots, from there delta value is greater than 0. Delta value means what? B square minus 4ac greater than 0. See, they mentioned that the equation has real roots, okay? But they won't mention whether the equation has distinct roots or equal roots. Okay, you need to maintain some clarity here. If they mention in the question that the equation has real distinct roots or real equal roots or real roots. If it is real distinct roots, surely delta greater than 0. If it is real equal roots, surely delta is equals to 0. If it is just real roots, we don't know whether the roots are distinct or equal. That's why you need to take that b square minus 4ac greater than or equals to 0. Then in that case, b square is what? Minus 4 square minus 4, a is t, c is 3 greater than or equals to 0. That's what we need to simplify. And on simplification, this is 16 minus 12t greater than or equals to 0. If you cancel out the 4, then what you have from this, by removing 4, 4 minus 3t greater than or equals to 0. 4 is greater than or equals to 3t, and 4 by 3 is greater than or equals to t, and in another way t value is less than or equals to 4 by 3. Have a look at this. The value of t is less than or equals to 4 by 3. Then what is the maximum value of t, if they may ask you? See, the maximum value of t is 4 by 3, because as per our discussion we found that the value of t is either 4 by 3 or less than 4 by 3. If you have an option related to that, the maximum value of t is 4 by 3, and that 4 by 3 value is approximately 1 point something. And if anybody asks you what is the maximum integral value for t, see, 4 by 3 is not an integer, but if they ask you to find the maximum integral value for t, below that 4 by 3, you need to choose an integer which is maximum possible for this t, and that is clearly what? 1, because 4 by 3 is 1 point something, so 1 is also allowed for t. But if 2 is taken in place of t, then the equation won't have real roots, right? That's why the range of t is less than or equals to 4 by 3. Based on this range, again you may get different options in your question, right? Related to this range, you need to choose the corresponding option, okay? And once again, look at the question. As they mentioned that this equation has real roots, and you need to think about t value of t. For that, what I did, if you compare with the usual general form, a, b, c I have, and from there delta I calculated, and that delta value is greater than 0 because it has real roots. Since they mention just real, they won't specifically mention whether they are equal or not. That's why we need to take greater than or equals to 0. Since it is greater than or equals to 0, t value is less than or equals to 4 by 3. From there it is very clear that the maximum value of t is 4 by 3. There ends the third bit of the 16th one related to the nature of the roots. And now the last one, the question says us that the roots of this equation are equal. Yeah, as they mentioned that the roots of this equation are equal, we need to equalize the delta is equals to 0, because it has equal roots, that in the sense only one root, so you need to make delta is equals to 0, then by that find the value of m. Yeah, after this try to complete this last one. Yeah, see, now since as they mentioned that this equation has equal roots, since it has equal roots, what I am going to do, I will do that delta is equals to 0. Then if you compare with our general form, a is equals to the coefficient of x square 3m plus 1, b is equals to coefficient of x which is 2 times of m plus 1, c is equals to constant which is m. Now since the equation has equal roots, as they mentioned that the equation has equal roots, that's why we need to equalize the delta is equals to 0. What is delta actually? Delta is b square minus 4ac, and that is equals to 0. And now these are the values of ABC. Use this ABC in b square minus 4ac and then get the values of m here. B square, see, 2 times of m plus 1 whole square minus 4 times of a is 3m plus 1 and c is m is equals to 0. And now look here, 2 square is 4 and here also I have 4. So since it is equals to 0, just remove that 4. In the next step what I have? M plus 1 whole square minus m into 3m plus 1 is equals to 0. Look this, for the space concern I am arranging this. See, I have a question and they mentioned that the roots of this equation are equal. Since the roots of this equation are equal, its delta is 0. What is delta here? B square minus 4ac. So equalize it to 0 to get the values of m. And now, see, you need to simplify. M plus 1 whole square minus m into 3m plus 1, and that is equals to m square plus 2m plus 1. M into 3m is 3m square minus 3m square minus m into 1 is minus m is equals to 0. And now, since they asked us to find the values of m, try to make a quadratic in terms of m and solve it. M square minus 3m square minus 2m square, 2m minus m plus m, and that is plus 1 is equals to 0. See, we need to find the values of m, multiply with minus 2m square minus m minus 1 is equals to 0. Think about it. Whether any factorization possible here, or we may move with the quadratic formula again, because it is a quadratic equation in terms of m. I think so there is a possibility for the factorization. If I write like this, 2m minus 1 into m plus 1 is equals to 0, what will happen? Think a while. See, 2m square plus 2m minus m. Yeah. See, take here it is plus and there it is minus. Now it is correct, right? Minus 2m plus m is minus m and then minus 1. So it's a correct factorization for this quadratic. And from there, the product is 0. Either that is 0 or this is 0. Then the possible values of m are minus 1 by 2 or 1. See, think a while. See, the given equation what we arranged actually has equal roots only if the value of m is either minus 1 by 2 or 1. Since the question mentions about the nature of the roots as equal, that's why we equalized the delta to 0. And these are the values of ABC. Use here to get the value of m. At the end, answer for this question is m is equals to minus 1 by 2 or 1. Have a look at this, and these are few simple problems related to the nature of roots. Have a look. Since we are going to draw the graphs of the quadratic expression, first of all you need to think about the graph. What is a graph actually? See, for a graph, if you draw anywhere, you need a relation between the two variables. You may say them as y and x. Y is equals to f of x, or y is equals to ax square plus bx plus c. Right? In other words, what I am going to tell you is what the graph usually describes. A graph usually describes the nature of one variable with respect to the other variable. Is it clear? So usually in a graph we will see two lines. Say, okay, horizontal line and the vertical line. That horizontal line is usually the x-axis, whereas the vertical line is the y-axis. I think you know all these things, right? And now see what the graph shows. What the graph indicates is the graph indicates the nature of y with respect to the nature of x. See, the value of x is changing in different manners. But what you say about the values of x? See, in another way, what I am going to tell you is, for example, if you have either y is equals to f of x or either y is equals to ax square plus bx plus c, in the right side, variable x is involved, in the left side, variable y is involved. This variable x is usually called as independent variable. What we will say? Independent. And whereas this variable y is usually called as dependent variable. Okay, dependent variable. And that is independent variable. Why we are calling that y as dependent variable and x as independent variable? The value of y, it depends on x, that's why we call it as dependent, and the value of this x is independent. We can take any value, that's why we call it as independent variable. So we have a chance to change that x, and that x we need to calculate the value of y. For example, usually while watching the cricket matches, you will see different graphs on your TV screens, right? What the TV screen shows? The TV screen shows graphs related to the runs made by a cricketer, or the scores, how they are changing for the total team. Usually we will face. On the horizontal line, usually they indicate the overs. Yeah, in the first over, maybe in the fifth over, or maybe in the 10th over, usually they indicate. And in the vertical line, you may see the score. After the first over, the score may be 10. And after the second over, the score may be 30. And after the 13th over, yeah, the score may be 40 or like that. See, on this horizontal line, we usually are taking runs like, overs, okay? Overs, or sometimes maybe balls, number of balls. But whereas on y-axis, you may take the scores, runs, okay? and the points are corresponds to the score in 1 over, score in 5 overs, score in 10 overs, like that we usually consider. And if you look at the graph, if the graph looks like this, yeah, if the graph looks like this, it indicates that, see, while moving from the first over to fifth over, the score is rising. Whereas while moving from the fifth over to 10th over, the score is rising in the sense the score is a constant, like that. See, usually these graphs are helpful to analyze the complete picture within fraction of seconds, right? See, an information is usually represented by many ways, either by tabular way or by paragraphical way or by graphical way, like that. Okay, and now the graphical way helps us to analyze the given information in fraction of seconds. Here the quadratic. See, if you look at this, if you change the values of x, the y values will change. What I am going to tell you is, for example, if I have an expression like y is equals to x square minus 5x plus c, what to say about the value of y depending on the values of x. See, the values of x, I have an independent chance to take any value in the place of x, but I don't have that independent chance depending on the value of y. For example, if I take x value as 0, then what you will say? If x is equals to 0, then for sure the value of y will become 6. Is it right? If x is 0, y is 1. Is it okay? Not okay, right? See, if x is 0, then for sure we have only unique possible value for y. That's why y is not independent. Y is surely dependent on 0. Okay? See, we are not allowed to fix both the values x and y. We are allowed to take only either x or y. If one value is fixed, depending on that other value we will find. See, usually the values of x, we may take any values in the place of x. Depending on those values, we will get the values of y. Or for suppose x is equals to 1, what to say about the result? 1 minus 5 plus 6, it is 2. If x is equals to 2, x is 2, then what you say? If you simplify 2 square and then the result is 0. Is it clear? Yeah. And for example, if x is equals to minus 1, if x is equals to 1 by 2, if x is equals to 2, if x is equals to minus 2, minus 3 and everything. See, in the place of x, you have infinite number of chances to take. Any value just take in the place of x. Corresponding to all those values, you will get different y values. And now, after analyzing, we are going to draw the graph. And after drawing and after analyzing the graph, see, we are after analyzing the graph, we have chances to decide whenever the values of y is positive, depending on the values of x. Whenever the values of y are negative, depending on the values of x. Whenever the values of y are increasing, whenever the values of y are decreasing, depending on the values of x. Whenever the value of y is maximum, whenever the value of y is minimum, depending on the values of x. All these are different conclusions which we generate from the graphs. Is it clear? So first of all, to conclude all those, we need to learn how to draw the graph. We need to learn how to draw the rough graph at least. Right? So first of all, to draw the graph, see, making these type of tables and indicating the points related to these values in the graph sheet, and we need to join all those things. Okay? First of all, have a look at this. What I am going to tell you is, once again, see, if y is equals to f of x and y is equals to ax square plus bx plus c, there is a relation between the variables x and y. So we need that relation actually. So in those relation, one value is independent and one value is dependent. By changing the independent variable, we will get different values without our involvement for dependent variable. And by relating those independent and dependent variables, we will draw graphs. Is it clear? So, in particular, we have to discuss about the quadratic. And now, for example, I took the quadratic as y is equals to what? X square minus 5x plus 6. If you take different values in the place of x, you may get different values for the y. And to draw the graph for this, y is equals to x square minus 5x plus 6, we need to draw the graph in the graph sheet. That in the sense, we need to draw the graph in the coordinate system, and we know that this is origin, and this horizontal line is for the values of x, this vertical line is for the values of y, and the first relation is 0, 6. X is 0, y is 6. As we know that this is for x and this is for y, so x is 0 and y is 6. Where it happens, x is 0 and y is 6 means on the y-axis you need to indicate a number where it is that 0, 6. And x is equals to 1 and y is equals to 2, this is the point. And x is equals to 2, yeah, this is x-axis, whereas y is 0, y0 means this is the point. And if you move for 3 also it is 0, right? Like that we have to indicate. See, after finding all those values, if you join all those, you may get a graph like this, and this is the rough sketch for that y is equals to x square minus 5x plus 6. Okay, in your own way, just take 2-3 quadratic expressions and then try to draw their graphs by making such tables, right? And from there I will continue in the next session, right? Have a look at this. So see, your work is to draw at least 3 to 4 graphs by taking different quadratic expressions like this and make a table. Try to draw its rough sketch by indicating the points. Okay, you just use white paper, no need of graph sheets and everything, right? Have a look at this now.